Okay, so today we're going to talk about the differences between molarity and molality. Before we talk about the differences between this, let's talk about the similarities. So first of all, molarity and molality is about the units we need to express concentration of a solute in a solvent in chemistry. So molarity, now these are the differences. So molarity is equal to moles of solute divided by liters of solution. Remember from previous videos that solution is solute, the amount of solute, plus the amount of solvent. And molality is moles of solute divided by kilograms of solvent. If you need to further review the difference between a solute and a solvent, please go to my other videos about solutions. So if we say that we have a 0.08 molar of sodium chloride, this means that we have 0.08 moles of sodium chloride divided by 1 liter of the solution of sodium chloride. And molarity is always depicted as a capital M. If we say that we have a 0.025 molal of potassium hydroxide, this means we have a 0.025 moles of potassium hydroxide divided by 1 kilogram of solvent. And usually, most of the time, the solvent we're talking about is pure water. And molality is designated as a lowercase m. Okay, so let's do some problems dealing with molarity and molality. What is the molarity and molality of a solution if 2.55 grams of sodium bromide is dissolved in 370 milliliters of water? The density of the resulting solution is 1.12 grams per milliliter. The density of pure water is 1 gram per milliliter. So in this case, we can actually find molality pretty quick. So again, what is molality? So molality is equal to moles of sodium bromide divided by kilograms of the pure water, which is the solvent, kilograms of H2O. So to find moles of sodium chloride, we have 2.55 grams of sodium bromide so we will divide by the molecular weight of sodium bromide. So grams of sodium bromide cancels grams of sodium bromide. Our answer here will be in moles of sodium bromide. And so we have 0.0248 moles of sodium bromide. So that will be our number in the numerator. Now for the number in the denominator, we need kilograms of water. Well, the question says we have 307 milliliters of water. We know that the density of pure water is 1 gram per mil, so 1 gram of water is equivalent to 1 milliliter of water. Milliliters of water cancel out milliliters of water. We have now, at this point, grams of water, but we need to make into kilograms of water. So we know 1,000 grams is equal to 1 kilogram. 1 gram of water here cancels out this. Our answer at this point will be in kilograms of water. And this is 0.307 kilograms of water. So we put this in our denominator and solve for molality. And our answer is 0.0808 molal of sodium bromide. So this is the molality of our solution. To find out the molarity of the solution, again, molarity is equal to the moles of sodium bromide, same exact numerator as molality, but the denominator is going to be about liters of solution. So we have to find this number here. Well, we are given the density of the solution. So how do we find this out? So, well, from the previous example, we know that 307 milliliters of water, because of the density of 1 gram per mil of water, this is equal to 370 grams of water. That is our solvent mass. Well, we have 2.55 grams of sodium bromide. This is the mass of our solute. If we add these two together, we get 309.55 grams of solution, because solution is solvent plus solute. So this is the weight of our solution. Since we know now the weight of our solution, and we know the density of our solution, which is 1.12 grams per 1 mil, we can figure out our milliliters of solution. This comes out to be 276 milliliters of our solution. For molarity, we need liters of solution and not milliliters of solution. So turning 276 milliliters of solution to liters of solution, just divide this number by 1,000, and we get 0.276 liters of solution. That is the number we put in here. So now with just one more calculation, we take 0.0248 moles of sodium bromide divided by 0.276 liters, and we get the molarity to be 0.0898 molarity of sodium bromide. Okay, so let's do this next problem. It's in two parts. So first part is how many milliliters of water was used to produce a 0.88 molal solution of lithium bromide with 64 grams of lithium bromide. So this one, again, molality is equal to moles of lithium bromide divided by kilograms of the solvent. So obviously the solvent here is water, so kilograms of water. Well, we're given the molality, so we're looking for this first. So, since we know we have 64 grams of lithium bromide, let's find the moles of lithium bromide. That means we'll divide it by the molecular weight of lithium bromide, which is 86.85 grams of lithium bromide, is equivalent to 1 mole of lithium bromide. So we get 0.737 moles of lithium bromide. So since we know our moles of lithium bromide, and we know molality of lithium bromide, which is here, 0.88 moles of lithium bromide, that's equivalent to 1 kilogram of water. So this expression here is just molality flipped, or the reciprocal of the molality given above. So this will give us kilograms of water. So this will give us 0.837 kilograms of water. But the question is, how many milliliters of water is this? Well, we know from the density of water that density of water is 1 gram per milliliter. So we'll use that in the next calculation. Since we know the density of water is 1 gram of water is equal to 1 milliliter of water, that's the same thing as saying 1,000, same thing as saying 1 kilogram of water is equivalent to 1,000 milliliters of water. So our answer here is 837 milliliters of water for the first answer for this first part of this question. Again, this conversion here is because 1 gram of water is equal to 1 milliliter of water, so that is equivalent to 1,000 grams of water is equivalent to 1,000 milliliters of water. And 1,000 grams of water is 1 kilogram. Okay, so to find out the molarity of the solution, I put up here the answers we found out in the previous question. So again, we know that there are 0.737 moles of lithium bromide, and we know that we have 837 milliliters of water. So to find molarity, again, molarity is equal to moles of lithium bromide, which we already have here. We need to find liters of solution. So we need to find this number here. So to find liters of solution, we can find grams of solution first, and then using density, we can convert grams of solution into liters of solution. So let us figure out what is the grams of solution. So we know that we have 837 milliliters of water. We know the density of pure water is 1 gram per 1 milliliter. So this gives us 837 grams of our solvent, which is water. We know that we started off with 64 grams of solute. So 64 grams of lithium bromide is our solute. Again, this is our solvent. This is our solute. We add them together and we will get our grams of solution. That comes out to be 901 grams of our solution. Since we now know the grams of solution, we multiply that by the density of solution, which is given here as 1.04 grams is equal to 1 milliliter of the solution. Grams of solution cancel out grams of solution. We get milliliters of solution, which is 866 milliliters of solution. We can change milliliters of solution to liters of solution. 0.866 liters of solution And this is the number that we're going to plug into here. So now we have 0.737 moles of lithium bromide divided by 0.866 liters of solution, and that gives our molarity to be as 0.851 molarity of lithium bromide. So this is the answer to the second part.